4.6 is all about completing the square. But before we do that, we first need to learn how to solve problems by finding square roots. This works when we only have one x term. We want to isolate it, so we're going to subtract 10 on both sides, leaving us with 4x squared equals 36. Then, to further isolate it, divide both sides by 4, which gives x squared equals 9. Now we can take the square root of both sides. Now remember, when we take the square root, it's saying what two numbers multiply together to get us back to 9. This means we have two solutions. X could be equal to positive 3, or x could be equal to negative 3, because negative 3 times negative 3 is 9, and 3 times 3 is also 9. Next example, we're going to subtract 14 to both sides, so negative 2x squared equals negative 64. Divide by negative 2, so x squared is equal to 32. Again, we're going to take the square root of both sides, but this time 32 is not a perfect square, so we're going to simplify this down. We can say that 32 is the same thing as 16 times 2, and 16 is the same thing as 4 times 4. Since we're taking the square root, that means we're looking for groups of 2. We can take out one of these 4s, and that leaves the 2 on the inside. So the square root of 32 becomes x equals 4 times the square root of 2. Now we also have to remember that since we're taking the square root, we do get two solutions. So make sure to add that plus or minus in front. Example 2 is another special case of factoring, specifically with trinomials. And essentially what it's saying is if we can rewrite the first term as a perfect square and the last term as a perfect square, and the middle term is 2 times whatever your perfect squares are, then this is the equivalent factored format, and it's a shortcut for factoring. On our first example, if we took the square root of 16x squared, well, that's going to be 4x. But if we want to get back to where we started, we'd have to square that entire thing. Then if we take the square root of our constant term of 1, well, that's the same thing as 1, and we'd have to square it to get back to where we started. So now we know that our a value is 4x and our b value is 1. Next, we need to look to see what is the value of our b term. Well, our b term is positive, and whenever the b term is positive, that tells us that a plus b all squared is our factored format. So this would become 4x plus 1 all squared. But this is all still equal to 81. If we want to isolate x, we're going to have to take the square root of both sides. And remember, taking the square root always produces two solutions, a positive and a negative one. So 4x plus 1 could be equal to positive 9, and 4x plus 1 could be equal to negative 9, since that is the square root of 81. Then we're going to solve each equation for x. Subtract 1 to both sides, so 4x equals 8, divide by 4, and x is equal to 2 for the first solution. On the other one, subtract 1 to both sides, so 4x equals negative 10, divide by 4, and we're going to need to reduce this fraction, divide both of them by 2, which gives a solution of negative 5 halves. Let's try one more of these. Again, we're going to take the square root of the first term, which would be x. We will take the square root of that constant, which is 5, and this gives us that a is equal to x and b is equal to 5. Then, since we are using subtraction for our middle term, we need to use that a minus b squared is the factored format, which means x minus 5 all squared is equal to 100. Take the square root of both sides, and x minus 5 equals positive 10, but x minus 5 also equals a negative 10. Add 5 to both sides, so x is equal to 15. On the other one, add 5, and x is equal to negative 5. And here are our two solutions. Next up is completing the square. This is a way to make a perfect square trinomial out of any equation, because they're not always going to come out nice or be given to you nicely like they were in example 2. Now that you've done the investigation, you've realized that we can complete the square in a couple different ways. If we were looking at these squares given, we could say, well, this is x by x for the length and the width, meaning the area of this tile is x squared. For the long rectangles, this would be 1 for the length, and then we have x for the width, which means that each of these long rectangles could be represented by a single x. So if we want to figure out what completes this area right down in here, we would need to have 9 single 1x1 tiles in order to complete our square. Now because of this, we can represent this area in 2 ways. The first way is as a sum of the values, meaning we have 1 x squared tile, but then we have 6 of our lines, so that would be plus 6x, and then we have 9 dots, so plus 9. The second way we could do it is as a product of the length times the width. Well, if we're going to represent our length right here, we have an x, but we also have 3 1s, which means this could be x plus 3. If we look for the width, we have x and 3 1s, which is also x plus 3. Well, that's the same thing as x plus 3 squared. So this is showing us that when we're given any type of problem, we can take it from standard form and we can turn it into factored form using the completing the square method. If we want to find what value completes the square for the given equation, we need to use the formula for completing the square, which tells us that the value that completes it is b over 2 all squared. Well, here our b value is whatever's in front of the x, which is -7. So we're going to plug that in. It's going to be -7 over 2 all squared. Well, that means that's the same thing as -7 over 2 times -7 over 2, which is 49 over 4. This is the value that completes our square. Now that we have all the bits and pieces, we can put them together to solve a problem by completing the square. First thing we need to do is rewrite the equation in the form x squared plus bx equals c. That means we're going to get our x squared term on the left, our x term on the left, but our constant on the right-hand side. In the first example, we need to subtract x to both sides, but we also need to subtract 6 to both sides. That leaves us with 3x squared minus 12x equals -6. Step number 2 tells us that we need to make sure that the coefficient of x squared is 1. So we're going to divide by 3 to do that. So now x squared minus 4x equals -2. Then step number 3 tells us to complete the square by adding b over 2 squared to both sides of the equation. b is -4. We're going to divide that by 2 and square it, which gives us -2 squared, which is 4. So now we're going to rewrite the equation, x squared minus 4x, but we're going to add that 4 onto both sides. So the other side of the equation becomes -2, also plus 4. We can simplify on the right-hand side, which leaves us x squared minus 4x plus 4 is equal to +2. Now we have a perfect square trinomial. So we're ready for step number 4, and we're going to solve this just like we did in example number 3. Take the square root of x squared, so that tells us that a is x. Take the square root of 4, which tells us that b is 2. Using the perfect square trinomials rule, since we have subtraction for our middle term, we have to make this be x minus 2 all squared equals +2. Now we're ready for step number 5, where we can solve by taking the square root. Take the square root of both sides, and that tells us that x minus 2 equals the square root of 2, but also x minus 2 equals the negative square root of 2. Now to solve for x, we're going to add 2 to both sides, so x will equal 2 plus the square root of 2, and on the other side we also add 2, which means x equals 2 minus the square root of 2. And these are our 2 solutions. And we could not have gotten these by using our normal factoring methods, since they produce rather hairy decimals. This is why we need to know the method of completing the square. If you're doing the Bell assignment, you can stop here. If you're going to do the light bulb, then you need to watch and take notes on this next example. We're going to start off again by making sure that we have our x terms on the left-hand side and our constant term on the other, which would leave us with 2x squared minus 2x equals +9. Then we still need to make sure the coefficient on x squared is 1, so we'll divide everything by 2, which leaves us with x squared minus x equals 9 halves. For step 3, we need to complete the square by adding b over 2 squared to both sides, which would mean we have negative 1 over 2 all squared, which is positive 1/4. We'll rewrite it as x squared minus x plus 1/4 equals 9 halves plus 1/4. We do need to combine the like terms right here, and we know that 9 halves is the same thing as 18 over 4, add 1/4, and that will give us 19/4. So we'll rewrite the whole thing as x squared minus x plus 1/4 equals 19 over 4. Now we're ready to factor in step number 4. Take the square root of x squared, which is x, the square root of 1/4, which is 1/2, and we'll combine them with subtraction, square the entire thing, and that equals 19 over 4. Now for step number 5, we are ready to solve by taking the square root of both sides, which means x minus 1/2 is equal to positive square root of 19 over 4, and x minus 1/2 is equal to the negative square root of 19 over 4. On both sides, we will add 1/2, so x equals 1/2 plus the square root of 19 over 4, and x equals 1/2 minus the square root of 19 over 4. But we're not done just yet. We need to make sure we simplify under the square root as much as possible. We could rewrite the square root of 19 over 4 as the square root of 19 over the square root of 4, which is then the square root of 19 all over 2, giving us a final answer of x equals 1/2 plus 19 plus the square root of 19 all over 2, and x equals 1/2 minus the square root of 19 all over 2. And here are our two solutions when we're dealing with fractions in completing the square.